I'm going to go over some concepts in terms of basic application design, and I'll give you a fair warning. This may not make as much sense now as it will be a little further along in what we're going to do. Understand this is a bit complex, but if you stick with me, I promise you at some point it will click. And it's important, so we're going to get it out there now so that you get a chance to take a look and think about it a little bit. The way for many years, the most common way that applications have been developed, particularly in terms of website data driven applications, it's called Model View Controller. The Wikipedia tree on Model View Controller is a pretty good short introduction. I'll put the link in the description for this video, and you can take a look and read there for a little more in-depth explanation. But what we need to understand about model view controller designs is at what point in the bits and pieces of the collective group of bits and pieces that we would call a application, at what point do things happen? At what point does it do things? 15 years ago, if somebody were building some sort of data-driven website, what they would have is a database on the back. The database can also be called the model. It's the same thing. The database is the back end. That's the part that stores the data. In the middle, you have a view layer that takes the data that the user will eventually see and processes it in some way, manipulates it in a way that makes sense to what the user will see on the screen. And then there is a controller layer, which handles things like fetching requests back and forth between the user, the view, and the database. Manipulating the data as the user makes changes to the data and putting it back, and notifying the user that the data has changed. Stuff like that would be what we would consider the controller. And in the past, say 10 years, recent memory, a lot of this stuff has gotten closer to the user than the database. And the reason for this is a problem of scale, really. If you think back to the early 2000s, there were no social media networks then that 1 billion people used every day. There may have been the Googles and Yahoos of the world that 1 billion people would use every day, but that was pretty much it. Outside of the large search engines, there were not that many websites that got that much traffic at all hours of the day. But in the social media age, there are. And more importantly, with people doing the bulk of their web browsing and internet things on a phone, it's all hours of the day, which increases traffic and scale in its own right. Before there were phones that were capable of doing everything you needed to do on the internet, people were only going to be looking at the internet if they were in front of their laptop at best, or sitting at their desk in front of their monitor and their keyboard. These days, everybody's got a cell phone that can do most of what they do on the internet with them 24 hours a day. And people use the internet 24 hours a day. So the only way to accomplish all of this logic and processing required to support all of these people using the internet on their phones 24/7 is to put a lot of the processing logic onto the user's device. So we have seen a shift whereby most of this stuff is happening on your phone when you go to one of these services. On the back end, it's just data storage. You know, if Facebook or Twitter wants to change the way something happens on Facebook or Twitter, they can push an app update to your phone, and the app on your phone will make the change that they want to happen. It's not done in these middle layers like it was in the earlier days when everybody used the internet a lot less and only on a laptop or a desktop. So that's all fine and good if you have a social media network that 1 billion people are using. But more and more people are taking a look at this and saying, wait a minute, I'm not building Facebook or Twitter. I don't have 1 billion people using my thing. I'm talking about an internal business tool that maybe 10 people are going to use, or that maybe 50 or 100 people are going to use. In that case, the database that I'm using can do a lot of data logic on its own. It can do math on stuff that I ask it for. It can compare two things and allow me to easily take that data and build a chart or a graph. It can even do, say, geographic calculations and geographic drawings to render, map items. So why am I reinventing all these wheels when the database knows how to do all of those things? Why don't I let the database do its job? That's how we're getting to a lot of these low-code, drag-and-drop visual programming tools, is the database can do a lot of those things. And as we covered in the previous video, if we're using a common data language, for lack of a better word, between all of these things, if the user interface's data language, the ViewLogic's data language, the controller's data language are all the same, and we can put one piece in the middle that can translate that to the database so that the data language everywhere is the same, maybe we don't need separate ViewLogic. If the interface between the database and the user can handle requests and queries and notify the user when data has changed using the database's internal functionality, maybe we don't need a separate controller. Maybe we just have an API that interfaces between the user and the database that sorry, it's hard to draw with a big cursor. Maybe there's just the user interface in the database, and via an API that talks to the database for the user, you can do 90% of the logic on your data that you need done with the database's internal query capability. The database knows how to do this stuff. Databases are smart. People have been working on databases for many decades. It's only recently that people decided, we're going to reinvent all that. We don't need that. We're going to turn our database into a dumb data storage, application. Well, people are taking a second look at that and saying, maybe we're going to let the database do its job for a while. That's how we get to visual programming tools. It's relatively easy to make visual user interface components that just display data. You can display charts and graphs. You can display maps and put data points on them that have latitudes and longitudes. All that stuff is pretty simple to put together. You can even have tables that show you what's in your database and let you modify and change your customer's address, update their email, add and delete products from your products database. It's relatively easy to build all that stuff. And if you let the database do more work, you can have more simple drag and drop display components that don't require any custom view logic programming. And that's how we get to these visual development platforms that we're going to be talking about. Again, I know this seems complex if you're hearing all this for the first time, but as we go along, you'll find there are some things you can do by drag and drop, and some things just, won't be possible. It's still going to require some code. Just because you can drag and drop a chart and a graph and a table does not mean that you're going to build, Facebook or Twitter by drag and drop. I assure you it's not that easy. But that's not the end of the world. This is still an improvement. Imagine how much more efficient this can be if, for example, you can set up your data in your database. You can set up the API in the middle that lets you connect your charts, your graphs, your tables to your database and do 90% of all of the things that a typical data-driven website needs done. And for the 10% of things that you can't do without writing some code that are more complex than what drag and drop can accomplish, then you can turn it over to a freelancer or a contractor, or if your company's got software developers on staff, you can go to them and say, hey, I got 90% of what I need done here. Help me do the last couple of complex bits, and then we'll be on our way. That's still a lot more efficient and a lot more gentle on budgets and time than starting out with a blank whiteboard and 6 software developers and tens of thousands or hundreds of thousands of dollars to say, okay, we're going to design and build all this stuff from scratch. That's not necessary. If you can do 90% by drag and drop and plugging in tools that talk the same language, that's a much better way. And if you can hand that professional developer the 90% and say, I got 90%, do the 10% for me, and all of the heavy lifting design work has already been done, it's also easier, for one guy to do your 10% and deliver you a finished product within a week or two rather than over a period of multiple weeks or months and much greater expense. So, a recurring theme in all the stuff we're going to be talking about is getting back to the database. Getting back to the database is a lot of what makes all of this work. And like I said, if this seems like too much to grasp now, stick with me as we go along. It'll make a lot more sense. Thanks.